So lesson 7, visiting the state park. So it says entrance to a state park costs $6 per vehicle plus $2 per person in the vehicle. So how much would it cost for a car with 2 people to enter the park? So we know we have $2 per person and then $6 per vehicle. So we know we're going to have to add $6 to each of these. We know it's $2 per person. So 2 people, so it'd be 2 times 2, which is 4. But then we have to remember to add our vehicle cost, plus 6. So it costs $10 for 2 people to enter the park and 1 vehicle. Okay, so what about 4 people? How much would it cost them to enter the park if they were in the same vehicle? So 4 times 2 is 8. Then we have to remember to add our vehicle. So it's going to cost them $14. Okay, what about 10 people? What would be their total entrance cost? Well, we have 10 people that cost $2 each, which is 20. And then we have to pay for our vehicle. So it would cost them $26. Okay, it says for each row in the table, if each person in the vehicle splits the entrance cost equally, how much will each person pay? Well, so I know that for 2 people it costs 10 total dollars. So to figure out cost per person, we simply divide 10 divided by 2. So each person will pay $5. 14 divided by 4. So 14 divided by 4, each person will pay $3.50. And then for 10 people, if it costs $26 and they split it evenly, they would each pay $2.60. Okay, how might you determine the entrance cost for a bus with 50 people? Well, we know a bus is 1 vehicle, so there's $6. And then we know these 50 people have to pay $2 each. So we would want to find out how much it costs for the people. So 50 times 2. So it's $100 just for the people to get in, but then we have to pay for their vehicle. So we have an additional $6, which gives us $106. So is the relationship between the number of people and the total entrance cost a proportional relationship? Why or why not? Well, so to determine if it's something is a proportional relationship, we need to know if they are proportional, therefore do they have a constant of proportionality. And to determine that, we divide the right side, which is y, divided by the left side, which is x. Well, we've done that already here when we determine the cost per person. This is represented by y divided by x. So do we have the same constant of proportionality regardless of the number of people? And our answer is no. So they are not proportional because they do not have the same constant proportionality and they are not equivalent ratios. So here, if it was a proportional relationship and 2 people cost $10, then it should have cost $20 for 4 people. Okay. So 7.3, we have Han and Claire running laps around the track. And the coach recorded their times at the end of laps 2, 4, 6, and 8. So how many minutes per lap did it take Han when he ran 2 laps? Okay, so again, be minutes per lap, so it would be y divided by x. 4 divided by 2, which is 2. And then we have what amount of time per lap when there are 4 laps ran. 2.25. Okay, what about when he runs 6 laps? How long does it take him? He averages 2.5 minutes per lap. What about when he runs 8 laps? That would be an average of 2.875 minutes per lap. Okay, let's check out Claire. So in 2 laps, it took Claire 5 minutes instead of 4. So that would be 2.5 minutes per lap. Okay, and then when she ran 4 laps, if you notice, 2 times 2 is 4, and 5 times 2 is 10. So therefore, it should still be 2.5 minutes per lap. What about 6 laps? What was her speed or her pace? Okay, 2.5 minutes per lap. And then when she ran 8 laps, also 2.5 minutes per lap. So is Han running at a constant pace? What about Claire? And how can we be sure? Okay, so we know that Han's time varies depending on the amount of laps that he's running. So it doesn't seem like he's running at a constant pace, because here it only took 2 minutes per lap, whereas the more laps he ran, the longer it took per lap. So Han is not. What about Claire? Regardless of the number of laps she ran, her time stayed consistent. Therefore, she is running at a constant pace. Okay, so then it wants us to write an equation for the relationship between distance and time for anyone who is running at a constant pace. Well, we know Han is not running at a constant pace, and we know that Claire is. So what would be our equation? So let's use D for distance and T for time. And this is just our T divided by T. T divided by D, sorry. Okay, so we know that in order to determine the time that it took her to run, since she's running at a pace of 2.5 minutes per lap, then we would just want to multiply that times the number of laps, because 2 times 2.5 gives us 5. Same thing here. We're just multiplying by 2.5 each time. Therefore, our distance, our time equals our pace of 2.5 times the amount of laps that Claire is running. So what would be our second equation? So we could have also written this as T equals 5 divided by 2 times D. So what would be the second equation that we could write? Okay, so if we were given the amount of time that she ran, and we needed to figure out how many laps she could run in that time, then we would want to find an equation for D equals. So D equals, and we know if we have D here, our T will have to go here. And so when we switch our variables, that means we must use the reciprocal. So 5/2, the reciprocal of that is 2/5. So there's our second equation. Okay, so just lesson 7 summary. So Smoothie Shop A and Smoothie Shop B. So they both offer smoothies in the same number of ounces in the size. However, if you notice, the price is different depending on which shop you're at. So a 12-ounce drink at Smoothie Shop A is only $9, whereas that same amount of drink is $8 at Smoothie Shop B. So if we determine the cost per ounce, we see that Smoothie Shop A is charging a constant rate of 75 cents per ounce, regardless of what size drink they get. However, Smoothie Shop B cost per ounce is changing depending on how much they get. What could possibly be the reason that the price changes for getting a larger amount of a smoothie? Okay, so they're probably offering a discount. So the larger smoothie that you buy, they're charging less per ounce. So if we were shopping, if we wanted to purchase the smoothie, would we prefer to, as a individual, would we prefer to purchase it at Smoothie Shop B or Smoothie Shop A? We'd want to go to Smoothie Shop B because we're saving money. But which one is the proportional relationship? It would be Smoothie Shop A because no matter which size, they're charging 75 cents per ounce. Therefore, that is our proportional relationship, and this would be our given equation for that relationship.